So we're trying to solve this problem. What is the maximum vertical distance between the line y is equal to x plus 2 and the parabola x squared for all values of x in between -1 and 2? Alright, so this is what we call an optimization problem. And most optimization problems involve either the absolute minimum test, a maximum minimum test, or the first derivative test, or a combination of both, actually. So in this case, this is the first derivative test mixed with the maximum minimum test. And so what we really need to do is the first thing we need to do is take the first derivative and then find the critical numbers before anything. But before we do that, let's talk about what's going on in the problem intuitively. Alright, so the first thing we do is we sketch the function. Sketch first both functions. This line being x minus 2, and this being x squared. Keep in mind this graph is not drawn to scale. Okay, and so let's start dividing. So pretty much what we're trying to do is we're trying to find this vertical distance s that's in between the two. Okay, and then we say this vertical distance s is the top function minus the bottom function. And what we learn later on when we do applications of integral, it's really common for area as well. But we're trying to find this top distance, the maximum distance between the top function, the bottom function, and the easiest way to do that is to define a new variable. All right, so we said the vertical distance s is defined as the top function minus the bottom function. And we are doing this in respects to the x. So, therefore, our function of s is equal to the top function x minus 2 plugged in minus x squared. Okay, so then we take the first derivative to find the critical values. Alright, so the rate of change with respect to x of the vertical distance is equal to the derivative of the function, which comes out to be 1 minus 2x. Alright, to find the critical numbers, we set it equal to 0. Alright, so, and for simpler cases, I said let ds over dx equal s prime of x. Different notations. And s prime of x is equal to 1 minus 2x. Setting equal to 0, we find x is equal to 1/2. Okay, then, alright. From here, we apply the absolute maximum minimum test, and this is the absolute maximum minimum test. Absolute Extrema. Test. Okay, and what we do is we take that critical value we found, that 1/2 value we found, x is equal to 1/2. And we test there and at each endpoint. So we test at every critical value and each endpoint to find the absolute maximum. Whichever value is the highest, it's its maximum value. So we say, okay, so we start. It's easy to start at the critical value, for me at least. It doesn't really matter though. So I start at the first critical value, so it's 1/2. So 1/2. 1/2 plus 2 minus 1/2 squared is equal to 9/4. Simplifying it out. X is equal to -1. We found out it to be 0 by plugging into x. And alright, keep in mind we plug this back into the original. So note that we're going to plug it back into the original. Alright, so when we do any of these tests, we go back to the original function to determine, well, is this going to be a maximum or if it's going to be a minimum. Okay, so then then applying at the endpoints, we say, okay, these were zeros. So at -1, we found the function to be 0, and we found the function at 2 to be 0. All right. So we do know that this function has a maximum already, and I'll tell you why. This function here, okay, this function of s has a maximum. If you think about it, all right. So this is a parabola. with a minus x squared instead of a positive x squared, so it looks something like this. So this minus x squared forces it to be a maximum. So we're just trying to find this maximum value there, and we could do that using the vertex formula and then plugging it back in. That's one way of doing it, but a more realistic way to go for bigger polynomials, for more complex cases such as a cubic or a degree 4 or 5 polynomial, we would go down to using the first derivative test and also the the absolute extrema tests. All right, so and to close out the proof here. All right, so we know the maximum value is 9/4. So since S of t is a parabola with a maximum, and the zeros of S of t are -1 and 2, then the maximum value of x is 1/2. So this should be a S of x. Sorry, not t, x. And its value is 9/4. Okay. I hope that helps you guys out. We'll see you guys next time.